Good morning. Am I audible? Please respond in chat box. Okay. I think this is the last problem we discussed in the previous class. Limit x tends to 1, x power 1 divided by 1 minus x. Correct? This was the last problem. Fine. Next problem. Limit x tends to 0, cos x power 1 divided by x square. Limit x tends to 0, cos x power 1 divided by x square. First, try to identify the indeterminate form. That L is equal to limit x tends to 0, cos x power 1 by x square. Slides are not moving. Okay. Is it visible now? Abhinav? Okay. Do not mark your attendance now. Do not put your attendance now. Limit x tends to 0, cos x power 1 divided by x square. Let this be L. Let L is equal to limit x tends to 0, cos x whole power 1 by x square. As x tends to 0, base will be cos 0, and we know that cos 0 is 1. As x tends to 0, this will be cos 0, and the index will be 1 divided by 0. 1 by 0 is not defined, it is called infinity. Therefore, this takes in 1 power infinity form. We cannot use L'Hospital's rule. L'Hospital's rule is applicable only when the indeterminate form is either 0 by 0 or infinity by infinity. We cannot use L'Hospital's rule in this form, 1 power infinity. We can use L'Hospital's rule only when the indeterminate form is either 0 by 0 or infinity by infinity. Therefore, we have to convert this into either 0 by 0 or infinity by infinity form. For that purpose, take log on both sides. We get log L is equal to limit x tends to infinity log cos x power 1 divided by x square. Log cos x whole power 1 divided by x square. Clearly, it takes log m power n form that can be written as 1 by x square into log cos x. 1 by x square into log cos x, or this can be written as log cos x whole divided by x square. Log cos x whole divided by x square, this form. Now apply limits. As x tends to 0, numerator will be log cos 0. Log cos 0. And we know that cos 0 is equal to 1. Therefore, this is nothing but log 1. And log 1 is always 0. Therefore, numerator tends to 0. As x tends to 0, x square will be 0 square. That is also 0. Clearly, it takes 0 by 0 form. We can use L'Hospital's rule. Apply L'Hospital's rule. Keep left hand side as this log L. This is equal to limit x tends to 0. Differentiate numerator separately, differentiate denominator separately. That's what is called L'Hospital's rule. Do not use quotient rule. Derivative of log cos x is 1 by cos x into Derivative of log cos x is 1 by cos x into derivative of cos x is minus sin x. Therefore, minus sin x divided by cos x is tan x. Numerator is minus tan x divided by derivative of x square. Derivative of x square is 2x. Numerator is differentiated separately and denominator is differentiated separately. Now apply limits. As x tends to 0, I write here. As x tends to 0, sin theta by theta is always equal to 1. This is a known limit. Theta by sin theta is equal to 1. Tan theta divided by theta is equal to 1. Theta divided by tan theta is also equal to 1. As theta tends to 0, sin theta divided by theta is equal to 1. Theta divided by sin theta is equal to 1. Tan theta divided by theta is equal to 1. And theta divided by tan theta is equal to 1. Therefore, here minus 1 by 2 is a constant. Keep it as it is, minus 1 divided by 2. As x tends to 0, tan x by x is equal to 1. 1 into minus 1 by 2 is minus 1 by 2. Log L is equal to minus 1 by 2. Therefore, L is equal to e power minus 1 by 2. E power minus 1 by 2 means 1 divided by e power plus 1 by 2. Or this can be written as 1 divided by e power 1 by 2. Index 1 by 2 means square root of e. 1 divided by square root of e. Make a note of this. If you have any doubts, you can ask. You can mention in the chat box. Make a note of this. If it is over, we can move to the next problem. Is this clear? Samarth, is this clear? Shardi? Okay. Limit x tends to pi by 2 sin x for tan x. Limit x tends to pi by 2 sin x for tan x. This is the next problem. Let L is equal to limit x tends to pi by 2 sin x for tan x. Or try to identify the limit. L is equal to, as x tends to pi by 2, base will be sin pi by 2, and we know that sin pi by 2 is 1. And index will be tan pi by 2, and tan pi by 2 is infinity. 1 for infinity. For we cannot use L'Hospital's rule. Therefore, we try to convert this either into 0 by 0 or infinity by infinity for by taking log on both sides. Take log on both sides. Log L is equal to limit x tends to pi by 2 log sin x for tan x. How to write this? Log sin x for tan x. Clearly it takes log m for n for. Therefore, this can be written as tan x log sin x. Tan x into log sin x. Or this can be written as log sin x as it is into tan x. Tan x is the reciprocal of cot x. Therefore, tan x can be written as 1 divided by cot x. That's what I have written here. Limit x tends to pi by 2 log sin x divided by cot x. Now apply limits. As x tends to pi by 2, numerator will be log sin pi by 2. Numerator will be log sin pi by 2, and we know that sin pi by 2 is 1. Therefore, this is log 1, and log 1 is 0. divided by, as x tends to pi by 2, denominator will be cot pi by 2. Denominator will be cot pi by 2, and cot pi by 2 is also 0. Therefore, clearly it takes 0 by 0 form. We can use L'Hospital's rule. That means differentiate numerator separately, denominator separately without using quotient rule. Therefore, this is equal to derivative of log sin x is 1 by sin x into derivative of sin x is cos x. Cos x divided by sin x whole divided by derivative of cot x is minus cosecant square x. Therefore, log L is equal to limit x tends to pi by 2 cos x divided by sin x can be written as cot x divided by minus cosecant square x. Now apply limits. As x tends to pi by 2, numerator will be cot pi by 2. Cot pi by 2 is 0 divided by minus denominator will be cosecant square pi by 2. And we know that cosecant pi by 2 is 1. 1 square is 1. 0 divided by minus 1 and 0 divided by any finite quantity is 0. Therefore, log L is equal to 0. Log L is equal to 0 implies L is equal to e power 0. And what is e power 0? E power 0 is 1. L is equal to 1. This is the limit of the given function. Please make a note of this. If you have any doubts, you can communicate in chat box. Next one. Limit x tends to pi by 2 cos x whole power pi by 2 minus x. How is that L is in infinity form? Which problem? Problem number 5. Sujan? Previous. Which step? Then you can unmute yourself and ask. One power infinity form. This is sin x for tan x. As x tends to pi by 2, this will be sin pi by 2 whole power tan pi by 2. Then what is sin pi by 2? Sujan, what is sin pi by 2? 1 whole power tan pi by 2. What is tan pi by 2?
Infinity.
Infinity. Right. 1 for infinity form. Is that clear? Right. Limit x tends to pi by 2 cos x for pi by 2 minus x. Limit x tends to pi by 2 cos x for pi by 2 minus x. Let this be L. That L is equal to limit x tends to pi by 2 cos x whole power pi by 2 minus x. Try to identify the indeterminate form. As x tends to pi by 2, base will be cos pi by 2. What is cos pi by 2? What's cos pi by 2?
0.
0, right. Whole power, index will be pi by 2 minus pi by 2, and pi by 2 minus pi by 2 is 0. Clearly, this takes 0 by 0 form. We cannot use L'Hospital's rule. L'Hospital's rule is applicable only when the indeterminate form is 0 by 0 or infinity by infinity. Therefore, we have to convert this either into 0 by 0 or infinity by infinity form by taking log on both sides. Log L is equal to limit x tends to pi by 2. Apply log here. Log L is equal to limit x tends to pi by 2. If you apply log to RHS, it takes this form, log cos x power pi by 2 minus x. Log cos x whole power pi by 2 minus x. It takes log m power n form. Log m power n is n log m. Therefore, this can be written as pi by 2 minus x into log cos x. Pi by 2 minus x into log cos x. That's what I have written here. Pi by 2 minus x into log cos x. Our aim is to convert this either into 0 by 0 or infinity by infinity form. Therefore, we shall rewrite this function as log cos x. We keep it as it is, whole divided by 1 divided by pi by 2 minus x. There will be no change in the expression. It remains unchanged. If you transform this pi by 2 minus x to numerator, you get same term. Therefore, this can be written as pi by 2 minus x can be written as 1 over pi by 2 minus x. Now apply limits. As x tends to pi by 2, log cos x will be log cos pi by 2. And we know that cos pi by 2 is equal to 0. And log 0 is infinity. Therefore, numerator tends to infinity. And the denominator will be 1 divided by pi by 2 minus x, and x is again pi by 2. Therefore, 1 divided by 0 and 1 by 0 is again infinity. Therefore, this takes infinity by infinity form. We can use L'Hospital's rule. Apply L'Hospital's rule. Therefore, log L is equal to limit x tends to pi by 2. Log L is equal to limit x tends to pi by 2. Derivative of log cos x is 1 divided by cos x. This is 1 divided by cos x into derivative of cos x is minus sin x whole divided by derivative of 1 divided by pi by 2 minus x is minus 1 divided by pi by 2 minus x whole square into, correct? Derivative of 1 by x is minus 1 by x square. Similarly, derivative of 1 divided by pi by 2 minus x is minus 1 divided by pi by 2 minus x whole square into derivative of pi by 2 minus x is minus 1. Therefore, this is equal to limit x tends to pi by 2. Limit x tends to pi by 2 minus sin x divided by cos x is minus tan x. Minus tan x. Minus into minus plus 1 divided by pi by 2 minus x whole square. That's what I have written here. Minus sin x by cos x is tan x. You transform this pi by 2 minus x whole square to denominator. Divided by tan x means minus sin x divided by cos x. Minus sin x divided by cos x into pi by 2 minus x whole square. Apply limits and simplify. You do that. Apply limits. Derivative of log cos x is 1 by cos x into derivative of cos x is minus sin x. That's what I have written here. Minus sin x divided by cos x. Derivative of 1 divided by pi by 2 minus x whole square is minus 1 divided by pi by 2 minus x whole square. Into derivative of pi by 2 minus x is minus 1. Minus 1 into minus 1 is made plus 1 divided by pi by 2 minus x whole square. Therefore, this is equal to, you keep this negative sign as is, sin x into transform this pi by 2 minus x whole square to numerator divided by cos x. Apply limits. As x tends to pi by 2 minus pi by 2 is 0. 0 into anything is 0. Divided by denominator will be cos pi by 2 and cos pi by 2 is 0. Again, this takes 0 by 0 form. We can use L'Hospital's rule. Therefore, log L is equal to limit x tends to pi by 2. You keep this negative sign outside, minus into, differentiate this. This is first function and this is second function. Keep pi by 2 minus x whole square as it is. Derivative of sin x is cos x. Plus. Keep sin x as it is. Derivative of pi by 2 minus x whole square is 2 into pi by 2 minus x. Derivative of pi by 2 minus x is minus 1. Minus into plus is minus. That's what I have written here. Minus 2 into pi by 2 minus x sin x. Whole divided by derivative of cos x is minus sin x. Now apply limits. Apply limits. As x tends to pi by 2, numerator will be pi by 2 minus pi by 2 is 0. 0 into anything is 0. And here also pi by 2 minus pi by 2 is 0. 0 into anything is 0. Divided by denominator will be minus sin x. Minus sin pi by 2 is minus 1. 0 divided by any finite quantity is 0. Log L is equal to 0. Therefore, L is equal to e power 0. And e power 0 is 1. So make a note of this. Now mark your attendance. Mark your attendance along with your admission number. If you have any doubts, you can ask these in the chat box, or I'll repeat these problems again in the offline class also. If you have doubts, I'll repeat these problems in the offline class. Try this one. Limit x tends to pi by 2 secant x power cot x. Secant x power cot x. Let this be L. Let L is equal to limit x tends to pi by 2 secant x power cot x. Identify the indeterminate form. As x tends to pi by 2, base will be secant pi by 2, and we know that secant pi by 2 is infinity. And index will be cot pi by 2, and cot pi by 2 is 0. Therefore, this takes infinity or 0 form. We cannot use L'Hospital's rule. Take log on both sides. Log L is equal to limit x tends to pi by 2, log secant x power cot x. How do you write this? Log secant x whole power cot x. Now this takes log m power n form. This can be written as cot x into log secant x. Cot x into log secant x. Or this can be written as log secant x as it is. And cot is the reciprocal of tan. Therefore, this cot x can be written as 1 divided by tan x. 1 divided by tan x. That's what I have written here. Log secant x divided by tan x. Now apply limits. Log secant x divided by tan x, this term. As x tends to pi by 2, this is log secant pi by 2. Log secant pi by 2. And this is equal to log secant pi by 2 is 0 and log 0 is infinity. Divided by, as x tends to pi by 2, this will be tan pi by 2 and tan pi by 2 is also infinity. Therefore, this takes infinity by infinity form. Now we can use L'Hospital's rule. Differentiate numerator separately, denominator separately. What is derivative of log secant x? Derivative of log secant x is 1 by secant x. And the derivative of secant x is secant x into tan x. Cancel this secant x with this secant x, we get tan x in the numerator. Divided by derivative of tan x. Derivative of tan x is secant square x. Now apply limits. As x tends to pi by 2, numerator will be tan pi by 2 and tan pi by 2 is infinity. Divided by denominator is also